Hello, everyone. Thank you for joining the fourth webinar of the Reframed Tech Series, presented by the Pembina Institute's Buildings and Urban Solutions Program. Pembina is a national nonprofit clean energy think tank with offices across Canada. I'm speaking today from Vancouver, the traditional lands of the Musqueam, Squamish, and Tsleil-Waututh Nations. We work on policy in the areas of renewable energy, the clean economy, oil and gas, transportation, and of course, buildings. Before we start, I'd like to thank, of course, our funding partners, Natural Resources Canada, CMHC, FCM, and our supporting partners, Real Estate Foundation of British Columbia, Sitka Foundation, and North Family Foundation. So my name is Betsy Agar. I am a senior analyst at Pembina, and I have the pleasure of moderating this session. I'm joined by my colleague, Stephen Hoy, who is producing this series and leads our communications. Today's agenda is pretty straightforward. I'll start by introducing our Retrofit project, and then each of today's speakers. We will quickly move into presentations and follow them up with a Q&A. And finally, I'll leave you with some information about an upcoming demonstration project opportunity. So some housekeeping, just a reminder that this webinar is being recorded and will be published online, which we invite you to share with your networks. To ensure high sound quality, all participants will be muted throughout the webinar. If you have questions, please type them into the questions box on the GoToWebinar panel, and we'll try to answer as many of them as possible during the Q&A after all of the presentations are completed. So with that, I'm pleased to introduce you to Pembina's Reframed initiative. Through Reframed, we are working with designers, builders, owners, financiers, and policymakers to scale up deep retrofits. We believe that by bringing all of the players together to accelerate and improve retrofits, we can address our housing crunch and the climate emergency at the same time. What we mean by deep retrofits is that they're more than just energy and energy savings. They lead to healthier spaces, they're resilient and protect their occupants in extreme weather and seismic events, and of course, they're low carbon. And in scaling up retrofits, we have to keep additional goals in sight. Next slide. Just one back. Maybe we're missing it. We need to keep rent affordable through all this. We need to minimize tenant disruption, and we need to make sure that energy efficiency investments return the value that building owners and investors need to be confident in solutions. In the lead up to this, we produced a solar panel primer. Hopefully you had a chance to read it. If you haven't, you can find it in the handout section of the GoToWebinar panel, and it will be posted along with the recording of today's session. This primer is by no means comprehensive, but updates thinking around solar PV and its potential to help make the business case for the deep retrofits, which is the focus of today's webinar. So it's my pleasure to introduce our panelists for today, starting with Ed Nags. He's the VP at HES PV. His career has been focused on design and project management in the field of photovoltaics. He is a professional engineer with a degree in electrical engineering from Dalhousie University. He manages the HES engineering training and maintenance teams. He has over 15 years of experience with remote, storage-based, and grid-connected systems including repeaters, microgrids, net metering, and feed-in tariff systems. He has also designed curriculum for and facilitated seminars to educate technicians in the installation, marketing, and design of photovoltaic systems. Welcome, Ed.
Thank you.
After Ed, we'll hear from Ben Mills. He's a founding principal at Impact Engineering. You may have formerly known their former name as HIH. Ben sees his engineering practice as a way of inspiring people to reach for a more sustainable future. His objective is to push performance and ambition to achieve optimal occupant comfort through low energy, low carbon design. Ben has 15 years of diverse project experience, both in scale and strategy, including institutional and office buildings, MURBs, multi-unit residential buildings, and hospitals. Welcome, Ben. and Ken Crichton, Solar Business Development Manager at Penfolds Roofing and Solar. As a serial entrepreneur who started his first company at the age of 4, Ken has been on a lifelong mission to change minds to change the world. Ken has successfully spearheaded solar policy changes at the municipal level and continues to have his hand on the pulse of where solar energy is today and where we should be heading in the future. Ken's passion for the environment and his ability to take a complex subject like solar energy and tailor it for any audience has garnered him the well-deserved moniker Solar Ken. Welcome, Ken. Okay, Ed, over to you.
Okay, I assume you can all see my screen. So thanks, Betsy, and thanks for this opportunity. I think it's a very exciting area that we're going to cover today. You know, deep retrofits into multi-unit residential buildings is a really, really good opportunity for solar. And hopefully by the end of this webinar, you'll be able to see exactly what we mean by that. First, just a little bit about HES and who we are. We're a Canadian company with offices all across Canada. We've been in the industry with over 30 years of industry experience, so right back before you could actually connect power to the grid. And through that experience, you know, we try and advance the industry by helping with bringing down barriers. And I'll show you a little bit of how that has actually impacted the costs of solar systems. So I like to start this dive into multi-unit residential building PV costs with the global market. The graph depicts the PV market and the solar modules costs since 2009. One of the biggest contributors to the growth in PV is during the 5-year span you see on the graph from 2009 to 2014, the module costs actually plummeted 80% and continued to decrease thereafter. This was mainly due to the German feed-in tariff program at the time. That feed-in tariff created a huge demand, which manufacturing plants, mostly in China, ramped up very quickly to answer that call. They ramped up a little too quickly, which created an oversupply. That oversupply, of course, then drove the price down, which we have the luxury of using today, which actually finally makes the financial case work for solar systems. From there, the market continues to grow, hitting a peak of over 100 gigawatts last year. Most of the solar in 2019 was installed in China due to population, followed by India, the US, and then Japan. Canada's portion of this is currently quite small, but we do continue to grow. And one of the things about our growth is it's mostly organic growth, not dependent on programs. So we hope this will continue for many years to come. With the solar module costs at such a low point, the industry has shifted its focus onto the remainder of costs that make up the total install cost of the system. And this is where solar on multi-unit residential buildings have a big advantage, in particular in BC. The existing rooftop is a great platform for a low-cost mounting system. The electrical infrastructure is already in place to connect large systems, so that saves you money there. In BC, we now have the advantage of a low fixed electrical permit fee, which just came in January. So it's nice to see that helping with the overall cost. Also, as part of the BC Hydro net metering program, the interconnection fee for these types of buildings is typically 0. where in other jurisdictions they can be much, much higher. So now all we have to do is, get our installation labor and customer acquisition down, which will come as the systems become more popular and grow in number. But you can see the result in the table of some typical sizes that would go on to a MERB. So all the way from 27 kilowatts up to 150 kilowatts. Just one thing to note, our program in BC is limited to 100 kilowatts, but that's on the inverter side. So typically we're now seeing them go up to 1.5 times that with the solar side of things. So that's why this goes up to 150 kilowatts. But you can see that price all the way down to $1.88 a watt. I know when I put this out to the group, it was questioned as how this could be so low. And the big part of that is that is specific to MERB buildings and commercial buildings where they have the roof space and they have the electrical infrastructure. You have all these savings in BC where you can do things quite low cost. So this sort of the low cost lets us put things in perspective of what we call levelized cost of energy. For those who aren't familiar with this term, it's basically taking the lifetime cost for the installed system and dividing by its lifetime energy. Typically, we use a 25-year period for the lifetime of the energy, because that's the warranty period of the solar modules, which ends up giving you quite an attractive levelized cost of energy. This is also the same way that utilities will evaluate their assets as well. We need to sort of start to shift our thinking towards this levelized cost of energy when we're making decisions around the design, size, how the system should be implemented. One we always come across is the tilt angle for solar modules. If I tilt up, I'll get more energy, but what will it cost you to tilt up? And typically that doesn't actually work out. So on these types of buildings, we're usually installing a low slope mounting system because the cost to tilt up doesn't match the energy gained in that situation. Same thing with bifacial modules, tracking. In some cases, some module level electronics don't make sense. So it's always evaluating those against the energy. So look at the cost, look at the energy, and see if it's going to improve your levelized cost of energy. This all brings us to a point where we can now compare the levelized cost of energy for solar against the utility rates. You'll see here, I've translated those solar costs into what they would generate for a cost of energy. And you see that's in a range from just over 7 cents to just over 9 cents, depending on the system size and what it's going to cost you. And then below that, I've put in the typical rates that would be covered by these types of buildings for BC Hydro and for Nova Scotia Power, just to give you some comparisons across the country. You're either going to be in the small commercial service rate, which in BC Hydro is fixed at 12.4 cents. Nova Scotia has a two-tier system. And then on the residential BC, we have a two-tier system, and Nova Scotia has a fixed one-tier system. But you can see all of the rates, even at the smaller systems, are already well below those utility rates. So it's a good way to be able to compare. And then this was what will generate the excess cash that then can be applied later to the deeper retrofits. And that's going to be demonstrated in the later presentations. So here's a few key points to take away from this, and just in general about the solar energy industry. We've been trying to make the argument of environmental impact and all those sorts of things. Now with the lower cost, we're able to make the financial arguments, as I've shown in the earlier slides. But the big one a lot of people forget about is the jobs. Solar has one of the best job creation rates of 35 jobs per megawatt, 25 of those jobs being the installers. And the advantage to having a job industry like that is it's regionally diversified. So you're usually, wherever the solar is being installed is typically where the installers reside. So you're creating jobs in those local areas. So you get a nice diverse spread of where the jobs are being created across your province or country. So key fact to remember, 35 jobs per megawatt. And then the other one is that the cost for solar energy is such a low point now. It's one of the most competitive forms of energy that we can produce. And in 2018, we hit 2.9% of the global electricity demand, which is quite a nice number that's continuing to grow. So it'll be exciting to see where that ends up in 2019. And last key point is, of course, to remember that the MERB style buildings are ideal for solar retrofits. So with that, I'll pass it back. Thank you.
Thanks so much, Ed. It's good to see some updated numbers on that, and I'm sure that people, just to let everyone know that these slides will be made available afterwards, so you can take a closer look at some of those numbers. Now we bring Ben, who will talk to us a little bit about a case study on deep retrofit on a MERB.
Hey, good morning, everybody. It's Ben Mills here with Impact Engineering, and we're just delighted to be asked to be part of this. We really believe in the mandate of what Pembina is trying to do here, and it's been a wonderful education also working with Ed and Ken to understand how solar might change the way that we look at our typical retrofit projects. So my role here is to set up a typical MERB case study that's right in the wheelhouse of the Pembina Reframed initiative. I think many of you on the call will recognize this type of building. There's so many of them around the city. And if you'll indulge me, I just wanted to also give a little bit of a background on Impact, because many of you may not know us. And I think it will frame where our thinking is at, where the current kind of consulting engineering field is at. And I may even throw down a challenge there to my peers. So let's go for it. So this is what we'll be talking about today, which I've just described. So just wanted to highlight again how we're resonating a lot with the Reframed initiative in terms of especially the working in partnership aspect of this approach. We typically approach projects in a very open-minded way, where we try to pull the best ideas from all areas, whether they be from the contractors, the manufacturers, the suppliers, the consulting team, the owners, and so on. We have no monopoly over the best idea, and we really believe that in bringing the best ideas forward from the entire team, we can achieve these goals that Pembina is looking to achieve, and we've done so on projects. And I would just encourage everybody to keep that in mind as well as you're working with other stakeholders on your projects. The Pembina mandate basically matches exactly our mandate. This is like straight off of our website, but we're in the business of reducing operating costs and improving comfort. So we got to make a real difference for people who are paying the bills, people who are living in the buildings, and our third and final mandate that ties us all together is to decarbonize building operations, and that is consistent across all of our projects. And so it's nice to see a lot of this activity happening in the marketplace. This is just how we do it, and I think the key message here is that we take it from the very beginning, early planning and study phases, right through to what I call that optimized phase, which I usually refer to as the sciencey bit of the process. We've got real science tools that we use and apply on our projects, and those help us to get feedback and also to do design sizing. And I will touch on that a little bit later in the presentation, because I think it will be helpful for others who are working in this space, especially when we're electrifying buildings. Those are the wonderful people who do it all. Whole bunch of sharp looking individuals with lots of great experience. I think, modestly speaking, some of the top talent around in the area with a lot of experience to bring to the table. And in terms of deep retrofits and just kind of the focus we're looking at here, these are just a few, just to give some images of the type of projects we usually work on, which might frame your thinking around who we are and what we do and how we approach the case study coming up. Everything from large MERBs through to smaller projects, new construction and deep retrofits. But what ties all of these project types together is the fact that we are electrifying the projects across the board. And I should mention, I alluded to a bit of a challenge to the industry here. Our new construction side of things, we have a policy where we won't take on any new construction projects that have fossil fuels as part of the base building systems. And so I would throw that challenge out to other firms out there who are designing new construction projects. We've got a heck of a challenge ahead of us to try to decarbonize the building stock. And I think we just can't keep digging the hole any deeper. So we've made that policy position, and it's actually helped us to get on some really exciting projects and to challenge us and to challenge teams that might have ordinarily gone forward with projects that did have fossil fuels in them, to showcase the difference. So I think with a well done design, new construction, there's no need to be putting in fossil fuel infrastructure anymore. So I would just throw that challenge out there. Science tools, there they are. So we've got a bunch of them. I'll talk a little bit more about it, but suffice to say, blower door. I will talk more on the domestic hot water metering side of things because it's relevant to this particular retrofit case study. And one last thing I wanted to highlight here before we get into the case study, maybe just to frame up why this initiative is important and what's happening in the industry. There's obviously a trend towards decarbonization, and there's a mandate from governments at all levels. These are the targets that British Columbia government has set forward. And you can see, we're in the year 2020. We've got 10 years to get to this 40% reduction by 2030. And some of you may know that we're sitting right now around 2007 levels. So we've essentially made almost no reduction since 2007, meaning we've got to do that 40% in the next 10 years, which is a big lift. So we've got a big challenge ahead of us. Fortunately, some solutions, but it's going to require a lot of activity in the sector, which I think is good news for everybody on the webinar today, but the challenge is pretty immense. And the building stock itself hasn't really decarbonized very much since 2007 as well. I think we're even slightly up in the most recent surveys. So we have a lot of work to be done here. So without further ado, this is the case study. This is typical of many of our projects, but we've got a MERB here with 38 units. You can see the bedroom types here. So it's a bit more of a family building. It's the typical 3-story wood frame. It's got a parkade on level 1 that's above grade for the most part. You can see the square footage there, and you can see the age, about 1982. So it's really right up there in the sweet spot for envelope upgrades and mechanical system upgrades as well. Just as a note, I'm not deeply involved on the envelope side, so I'll talk about it a little bit, but we haven't gone into great depth. I'll focus more on the mechanical systems, but I'll provide context on envelope. So here's what it looks like in the proposed design after the retrofit. We are just in the design phase right now, so some of this may change, but we do have some of the numbers. The overall project looks to be achieving step 2. There was some question if step 3 might be possible. Still may be possible with the final package of measures, but step 2 looks like the likely scenario. And you can see there's a full package of envelope retrofits happening, and on the mechanical side, heat pump makeup air units on the roof, and then heat pump domestic hot water. The suites are currently electric baseboard heated at the moment, so those are staying as is. There's some actual photos of it. You'll see the roof there. Ken, when I pass it on to him, will get much more into the roof detail as it pertains to solar. But you can see you've got a nice flat roof, which is good for solar provision. And you can see what the building looks like on the exterior and what's going to be refaced there. Here are the existing conditions: envelope on the top row, mechanical on the bottom row. So again, very typical of something from this time period here, early 80s. Bad insulation in the walls for the exterior. At one point was tar and gravel, has moved to Tortron roofing, and it's got bad insulation below within the trusses. We've got double glazed aluminum windows, which makes me think this may be one of the first kind of the era to start getting double glazed. Maybe some other envelope experts can chime in on that, but just anecdotally, I live in a 1976 building and we've got single glazed aluminum. So I'm thinking somewhere there between 76 and 82, maybe that was getting more common to put in the double glazed systems. You can see on the mechanical side, we've got unheated rooftop fans. Again, somewhat typical of that time period. Kind of a serious problem because these fans, obviously bringing in totally unheated air, anytime the temperature is getting around that 5 Celsius or below mark, it just becomes really uncomfortable for residents in the building. And so the fans are actually shut off during those times. So not ideal by any stretch. There are door undercuts between the corridors and the residence suites. And they've got washroom exhaust fans, typical, just operating on wall switches, so intermittent operation there. Natural gas domestic hot water boiler. That boiler is about 10 years old, so still good life in it. The tanks are also 10 years old, so they need replacement. So here's the proposed retrofit. Envelope side, you can see what's happening with the walls, essentially adding 3 inches of exterior insulation. They're redoing the bats on the inside of the walls as well, just to freshen that up and to do a better job air sealing and weather protection. The roof, a couple of inches, actually up to 5 inches of polyiso, with a whole host of other layers there to make it work. Double glazed vinyl windows, so nothing extraordinary there. On the mechanical side, which is my focus, rooftop heat pump makeup airs, which we use frequently on projects. So I'll focus on those, and if people have questions about them, if you haven't used them, great systems. We're going to move to continuous washroom exhaust so that we can draw some of that corridor air into the suites and meet the minimum of the building code at any rate. And then the domestic hot water is going to move to a sand and CO2 domestic hot water system with several heat pumps and several tanks. So some details on the ventilation system. We have managed to increase the COP a little bit here, more than the ordinary, as well as in conjunction allowing it to operate at a lower temperature. We've done that by oversizing the heat pump section slightly. Minor costs to do so, but allows us to operate a little bit lower temperature more comfortably and gets us a little bit of a higher COP. So you can work with manufacturers to do that type of thing and then get them to send you, performance points at various temperatures, and then you can interpolate a COP. So we've done it hourly here in this case, based on outdoor air temperatures to get to that rough average COP. There are 3 makeup air units in total. So the building's actually divided in 3 sections with 3 different, or 2 fire breaks essentially. So like three buildings almost. And you do have the ability for cooling with these. So that's a nice benefit, talking about the resiliency aspect that Pembina is focused on and that a lot are focused on now in the deep retrofit world. Once we tighten these buildings up especially, and including the increased expected temperatures and climate projections, good idea to have some cooling available if you should need it. So our modeling doesn't include cooling use in terms of energy use at the moment, but certainly it's at least there and you're able to use it. As I mentioned, continuous washroom exhaust fans, and just to note that, the existing condition was those unheated fans. The baseline that we're comparing against for the purpose of the owner is a gas system. So we're not using the existing equipment since it doesn't really comply with any of the needs of the building or any of the code mandates. So financial performance, a whole bunch of numbers there, but looking at this, this measure in isolation, you can see the costs. The incremental is the difference again between the gas option. You can see the gas savings, you can see the electrical increase. We've implemented some controls here for this proposed case, as well as claimed some savings with better fan operation here to get that electrical increase as low as we can. So this is probably a good case scenario, I would say, based on the way we've approached this. We've got a good carbon reduction. You can see relatively good payback and other financial metrics. A note on this, and what's really important, I think, to realize is that those heat pump makeup air units do qualify for incentives through Clean BC. And when you include those incentives, the payback is really short. So this is where I say these are an excellent retrofit opportunity. In fact, the dollars per ton of carbon that Clean BC pays is much higher for rooftop heat pump equipment than just standard electrification equipment. So they're obviously recognizing that this is an easy retrofit to do and one that is attractive. So I'd encourage anybody replacing a rooftop unit to use something like this and claim those incentives. In our case, unfortunately, we cannot claim the incentives because we don't have gas already installed. So bummer for us, but normally that payback would actually be shorter than what we're showing here. Domestic hot water, so yeah, COP for the Sandon units, they can range as high as a COP of 5 in ideal conditions. That would be, with warmer outdoor air, ambient air that they're drawing from. So if you were in a parkade that was buried below ground, that would be a really good scenario. In our case, as I mentioned, we're above ground with the parkade for the most part, so we're not going to see that full benefit. Another note on these is they like to see really cold water returning to them. So the way you design up your schematic is important, and that will definitely affect the COP. So you can see the number of heat pumps we're looking at. You can see the number of tanks we're looking at. And I've mentioned maximizing the COP there. The baseline comparison in this case, because the boiler was still having a lot of life left, we can only really claim that we need to replace the tanks. So that's also why you'll see the payback when I go to the next slide is longer in this case. If the boiler was end of life, the paybacks would be a lot better. In this case, we have claimed incentives through Clean BC because we actually are decarbonizing. We're removing gas in this scenario, so positive for us. And I will touch on the fact later on in the project that this is our design sizing here. You can see with the 6 heat pumps and the 4 tanks. We are finding it's incredibly important to actually measure the domestic hot water use with a flow meter on projects where you're electrifying, because the cost of heat pump equipment is generally higher than gas, and it also takes up more space. And we've found across a lot of our projects, well, all of them, that the measured domestic hot water flow rates are actually much lower, much lower, I should even emphasize, than what we would normally calculate based on any of the methods you can think of, whether ASHRAE or ASPE or LEED. So a tool that should be in everybody's toolkit, I think, and I'll talk about that more. Here's the financial performance. So I alluded to the fact that it's not great, again, because the boiler wasn't end of life, so there was just nothing to claim there. I think the incentives we'll get at the end of the day will probably be a little bit better, so this will improve slightly, but relatively speaking, not a great payback in this scenario. And I think the key takeaway here is just that boiler is not end of life, so that would be a much better case if it was. However, if the owner does put a priority or a premium on decarbonizing, it does have somewhat of a payback, and equipment is not that costly to install. So what does the bundle look like if we're looking at ventilation and the domestic hot water system together? Obviously, the ventilation helps us with our case a little bit, so now we're down to an under 10-year simple payback, decent NPV, decent IRR. This is based on this particular client's economic metrics, and they're very particular about them. So each project will be different. This depends on the escalation rates used for electricity and gas, your discount rates, whether or not you add an in-house cost for carbon, and a few other factors. So this is just notional. This particular client is particularly sophisticated in terms of their financial analysis, so we've used their assumptions. But I would encourage people out there to have that conversation early on with your clients in terms of what financial assumptions make sense to them, or you can suggest ones that are more generic in nature. So this is just my last slide here before we pass it on to Ken to take a look at this project with solar installed, and then we'll come back to myself to see what's happened to the financial case. But critical next steps that we need to do, we need to understand if the existing electrical system can handle the added load that we're proposing. I believe it will because of the electric baseboard component. The system has been installed with a lot of capacity, but that's a critical step. And we have to do some structural analysis to make sure that the makeup areas don't need any major upgrades in the roof structure. They're about 1,000 pounds or so, or a bit more as compared to just those simple fans. And then domestic hot water metering, we talked about, those are those last kind of 2 photos on your right there. Those are the sensors that strap on. That's the actual logger there where we can get minute by minute data. And as I say, if anybody wants to talk to us about this more, this is a critical piece. We're working with some other players out there to engage in a study of this work, because if we're going to electrify domestic hot water systems, we really need better information on how to size them correctly. So with that, I will say thank you, and I'll be back after Ken.
Thanks so much, Ben. That's really helpful to see a case study, and we're really looking forward to see what Ken has to say to it. Go ahead, Ken.
Thank you, Betsy, and hello, good morning, and welcome. My name is Solar Ken. Well, not exactly what my parents named me. I added the Ken part later. Here's a shot of, I'm lucky enough to back onto a Salmon Creek in Port Moody. For those of you who don't know Penfolds Roofing and Solar, we're a large roofing company here in BC for over 80 years. We work within the Metro Vancouver area, from Whistler to Chilliwack, essentially. We got into solar a little over 5 years ago, and now with over 10,000 solar panels under our belt, we're the largest installer. So that brings a lot of good things with it, including tremendous buying power. Today, I want to talk quickly on some common solar myths, some common preconceptions, and then dive into the case study that Ben presented, looking at what that retrofit might look like with solar and what financial savings would come about. So first, let's talk about some solar myths. The most common being here in BC, people saying, well, how can solar possibly power my home, my business, my multifamily building? It rains too much here. And while it does rain a lot in the winter, our summers are fantastic for solar. And there's a few things about modern solar that you may not realize. It all equals Metro Vancouver is actually a great place for solar. Here's one of the reasons. So we're talking about solar PV or photovoltaics, which use the light energy of the sun to convert that light to usable electricity for your building. The solar cells, your active ingredient of the solar panel, are just like a computer chip. They don't like to be too hot. In fact, the hotter they are, the less they produce, or the cooler they are, the more they produce. So they love our temperate climate here in BC. It never gets too hot for them. There are areas of New York State that outperform Arizona for that reason. Solar panels can get so hot that they essentially shut off. Another reason why we're great for solar here is because we're northern, the length of our summer days are fantastic. Almost 2 hours longer than Los Angeles, for example. And the sun's up at a 64-degree angle at the solstice at solar noon, which is about 1 o'clock in the afternoon. Matched with tilted solar panels on your roof or on a sloped roof, that's almost that magic 90-degree angle that produces the most power. You know, if you compare us to Berlin, and Germany is the most solar installed country per capita, even though Berlin's not known for its sunshine, the same solar panel in Vancouver will produce 25% more power. You may not realize, but modern solar equipment doesn't need direct sunlight to produce energy. In fact, every minute of every daylight hour, your solar is going to produce energy for your building. Even on the darkest, rainiest day, that will happen. It will just produce less than if it was full sun. Of course, at night, it won't produce. People assume that they need batteries, and batteries are expensive. Used to be full of maintenance. The new lithium ones are better, but they are not that environmentally friendly. Thanks to the free net metering program that Ed touched on, 99% of the time, you won't need batteries. So here's an example of a grocery store. The key takeaways are that the solar panels, you already know that they're going to produce power every minute of every day. They're first going to feed any immediate electrical need within your building. In this case, it's the equipment inside the shelving needs 50 kilowatts. Well, the sun's low in the sky in this slide, so the solar is only producing 40. All of that 40 goes towards your building, but you need to top that up. And you bring in 10 kilowatts from the grid as you do now. This happens on a second-by-second basis, and the building owner, the occupants, the appliances, or any equipment in your building won't know the difference whether they're being powered by the solar or by the grid. But later on in the day, sun's out stronger, solar's now producing 80. You still need 50 for your building, for what's inside, solar provides all of that, but now you have an excess of 30. Well, that's not wasted. Thanks to the smart meter, which can record power flow in both directions, you shoot 30 kilowatts onto the grid. It's recorded as a power credit in kilowatt hours through your smart meter and becomes a credit account balance on your hydro bill. That means that excess power you can take back from the grid anytime in the future. It's a straight exchange. No money changes hands at this point. Think of it as using the BC Hydro grid as a giant battery, 100% efficiently, for free. This is great and dramatically has reduced the cost of going solar. Now, I should mention that the only time that you would possibly need storage or batteries is in the event of a power outage. When the grid goes down, the electrical code says that the solar system has to shut off immediately. If it didn't, it could send voltage onto the nearby lines, potentially endangering a line worker trying to restore power. So that's the only time, if you want to use the solar when the grid goes down, you'd need some form of storage or batteries in that instance. But most of the time, it's not needed. All of our systems come with free real-time monitoring. You get a smartphone app and a website, no monthly fee. You see what your system's producing in real time from anywhere in the world. For added peace of mind, if there's any malfunction whatsoever, the system will send you and us an email alerting you to what the issue is, although it's very rare. This is great at a dinner party. People often ask, are there incentives? And basically, yes, there is. In BC, we're lucky enough that solar is PST exempt. If you are a for-profit entity, a business, a farm, you can capitalize on a great federal solar tax incentive that came in late 2018. You can write off 100% of the cost in the year it's installed, potentially saving you an additional 28%. And the net metering program, which was a government program administered through Hydro, is free and does lower the cost. So it really is a form of an incentive. As you learn about solar today and perhaps in the future, most people love it. The only real stumbling block is coming up with the investment. And it is an investment, but it certainly pays off over time. There's a couple of great ways of financing it. Van City has a Prime Plus One loan for up to 15 years, up to $250,000 for commercial or multifamily. But if you still have a mortgage on the property, something magic happens. If you add the upfront cost of going solar to your mortgage, your bank will probably automatically say yes, because it won't change your debt service ratio. In other words, the value that the solar brings will quickly outweigh what the added loan payment would be. And in this example, it's in year one. So that's something very, very powerful. So let's look at this specific case. They're changing the roof. Previously, before retrofit, they had a few slope sections on the roof that are not going to be there. They're going to replace the roof, which is great for solar, because you're starting with a fresh new roof. Keep in mind, if you have 7 to 10 years life left in your roof, it's well worth going solar now. Typically, when you need to re-roof, because the solar will outlast the roof, most roofs, you do have to re the solar, which isn't that difficult for a flat roof, but there is some cost to it. But if you have 7 to 10 years of solar production, it's well worth it. So I want to delve into how I came to analyze this building for solar. So we've got some really fancy software. I created this 3D model of the building. You can see that I used satellite imagery, so the brown sections are the old sloped roof sections that are now going to be flat. I included all of the nearby trees and what we call protrusions on the roof, plumbing stacks, various mechanical equipment. This site is good for solar, but not great. And that's partly to do with the roof and the number of protrusions and the number of trees around. But it's a really fair example of what solar can do. Going back to the trees, this is how I arrived at the tree height in that neighborhood. So using LiDAR, essentially LiDAR means that at some point fairly recently, an airplane flew over this location with lasers. And you can see all the different laser points there that we turn into a mesh, and it shows the height of all the shade points in the neighborhood. So without the LiDAR, I know that those trees and the shade they represent are very accurate. Our software, I can't show you the exact software today, but it takes 30 years of historic weather data from the nearest airport, YVR in this case. It creates from that a typical weather year. And then it does something really interesting. It takes hour by hour sun path calculations throughout the year relative to the 3D model that I've built. And that's important because the sun's never in the same position twice throughout the year. So after running that scenario, it creates what's called an irradiance map on the roof. The lighter the color, the better. Essentially, I can tell what every square foot of this roof will produce for solar power each month of the year. And this is accurate within 1.8% of actual. Pretty amazing. So most of the roof, the good areas of the roof, are 86% of perfect. The lower number down at the bottom, the total solar resource fraction, is really the number that we use. Anything above 60% still builds a great financial case for solar. So let's look. So I also looked at the consumption of the building. So this is month by month, and for the year, pre-retrofit, what that building used for their common areas for electricity. You can see it's just over 69.5 thousand kilowatt hours. They were spending just over $10,000 a year. Typically, for common areas, building owners are charged at the residential rate structure from Hydro. Now, as Ben mentioned, especially when you're fuel switching and electrifying the building, it's great to decarbonize, but your electrical load will go up. And in this case, even though the electricity load now went up to 136,900, so slightly less than doubling the total amount of kilowatt hours, the yearly costs actually were just over double. And the reason why is because of how residential rates are paid for. Your first 8,100 kilowatt hours per year, and it is broken down by day, 22.1918 kilowatt hours per day, you pay a cheap step one rate. But above that, you're paying 50% more. So for this particular building, their blended cost, if you will, before retrofit was 13.6 cents per kilowatt hour. And after the retrofit, it would jump up to 13.8. But rates don't keep static, they keep going up. This chart was actually published by Hydro, I think it was in 2014 or 15 when they were applying to the Utilities Commission for a 28% 5-year increase in rates, which was approved. So it shows, the red bars show what the rates did that particular year. The purple line is the capital expenditures, in the highest being just over 2.6 billion. I won't get into the details of this, but just to show you that from 1973 till today, the average rate increase per year was 4.31%. So no one knows for sure what the next 20, 30, 40-year time period will be for rate escalation. So we use 4.3% in our assumptions, which we think is conservative. So for this particular project after retrofit, if they do nothing, there is a cost to that. We're projecting over the next 20 and 30 years how much they'd be paying to hydro for their power. You can see over 30 years, it's over $1.1 million. And you'll see in a second that if they go solar now, they can reduce that greatly because the solar is only going to cost them a little over $266,000. So what does that look like? Well, this building, I've pretty much filled it up with solar in the good usable spots. This is what I call a choppy array. The solar is kind of all over the place, and that does influence the cost a little bit. In order to get them to 100% solar powered, I had to also add a solar awning, which has some passive and active solar benefits. Interestingly, that awning, the solar panels there, the radiance of them is over 93% of perfect. So that they're actually catching more light than the flat areas of the roof, even though it is in a due west location. So, so with that system size, they get to just over 100% solar powered. And the graph below shows their consumption before and after going solar. You can see for the 6 months, especially in the summer there, they have excess production. The solar is producing in some months, over 200% of what they need. But thanks to the free net metering program, they're banking those kilowatt hours to use in the fall and winter. This is a great program. So financially, what does it look like? So we're assuming that 4.3% utility rate escalation per year. We've applied a 2% discount rate to essentially take inflation out of it. And I've run this as though they're a not-for-profit entity. So if they were to pay cash, their straight payback period would be just over 12 years, 12.31 years. But I would heavily encourage them to finance it. If they were to get financing as though it's a mortgage, like a mortgage style loan over a 25-year term at 2.5% interest rate, they will be cash flow positive in year one. So their costs after paying for that extra mortgage payment, they'll be $3,178 positive cash flow from going solar. Then that's in year one. So it's really quite amazing. Now I'm using 30 years as a useful project life. A well-made solar system will actually produce well beyond 30 years. And we're factoring in 0.7% per year degradation of the solar panels. They lose a little bit of efficiency over time. And depending on what solar panels you choose, that can go up or down. If they were a for-profit entity, let's say it's a rental building owned by a private individual, they could capitalize on the federal tax incentive, bringing their straight payback to under 10 years, 9.38, and be cash flow positive greatly in year one. So as a summary of that, if they financed 100% of it as the mortgage style, their net present value, today's dollars, the solar would be bringing them essentially $378,000 of savings, and that's after paying off the loan. The LCOE, the levelized cost of electricity, basically means that the solar over that time period is producing power at 10 cents a kilowatt hour. But if you remember, after retrofit, their blended cost was 13.8. So really, they're saving money from day one. It's just a matter of paying off that system cost. But in this instance, they're not paying upfront for the solar at all because it's being financed. So this net present value this additional benefit from the solar can be used to make deeper retrofits or to make the proposed retrofits more attractive and more bankable. So in summary, solar is going to lower your operating cost of your building because you'll always have some common area electricity. It'll lower your footprint. That's really a topic for another webinar. it's going to create positive cash flow. And in this instance, even though it's not a perfect building for solar, it was in year 1. And as I mentioned, you can use those savings for a deeper retrofit or to make your existing retrofits more bankable and attractive. So, you know, oh, drummer was a little little premature on that. I wanted to throw in a corny joke. What do you call a massive solar spill? A nice day. That's where the drummer should have come in. At Penfolds, we like to say, put your roof to work for you. So thank you, and I'll pass along my contact information as well.
Ben, Ken, thanks so much for that corny joke. Just quickly before we switch over to Ben, because we're really interested to see how that is integrated into his case study. There are a couple of questions here asking about the software for the EPV model that you're using, and you know, is it available to others, or is that proprietary to Penfolds?
It's not proprietary to us, but it's a bit of a trade secret, if you will. It's quite expensive software, but it's somewhat commonly used in the solar industry.
All right, I'll leave it to folks to contact you directly on that.
Sure.
Ben, back over to you quickly, and then we'll move into Q&A.
All right, great. So hopefully this slide has come back up here. Thanks, Ken. That was super interesting. So as we said, we left off here at these critical next steps, understanding our capacities and our structural implications and so on. Now let's go forward one here. Let's just remember what this retrofit bundle looked like prior to considering solar on this project. So you can see a simple payback about 10 years or so. You know, we're not really cash flow positive in any sense here. We're working our way backwards out of a hole. You can see the net present value there is about $26,000. So using some of Ken's financial analysis, recall that he had about just over $3,000 in the first year of cash flow, and then that escalates based on the increase in electricity costs. This is what things look like after adding in that solar component. So, you know, over $3,100 positive cash flow in the first year, and all of a sudden our net present value just on these two measures has increased greatly, as well as our rate of return. So I think it does paint a pretty compelling picture that, as Ken said, you know, if you can finance the solar, if you can get access to the cash for the solar, it's a great feature to be including as a measure in your deep retrofit. And it certainly helps with electrification, where we're increasing electrical energy use with a really substantial offset that not only offsets it, but also provides you positive cash flow. So I would say on our end, this was a really big learning point here. We didn't anticipate that the performance of solar would be as good as it is. It obviously requires the right kind of project and the right people to be involved. And every building is different based on its location and the roof type and so on, and the age of the roof. But I would encourage others to consider solar on their projects as well, because I know we will be. And certainly when we're electrifying, I think it's a great opportunity. So I'll close there because I think that picture probably tells the story, and I'll leave my contact information as well and pass it back to Betsy for the Q&A.
Thanks, gentlemen. That's it's really great to see some updated numbers on solar, and maybe it jogs our thinking a little bit on how we treat it. We are going to enter into a Q&A period. So we will kick that off with a poll as promised. Just waiting for the poll to come up. Here we go. Just want to ask a question about, you know, what factors most improve the economics of integrating solar PV into a deep retrofit? You can answer as many as you want. And if there are some we've missed here, please feel free to enter them into the chat. For 10 more seconds. All right, looks good. So, what factors most improve the economics of integrating solar PV into a deep retrofit? 76% heard physical attributes of the roof, building, and site. 65% heard economies of scale with increasing the system size. 61% coordination with other aspects of retrofit bundle. 46% customer rate to be displaced by solar electricity. And last in that list, utility restrictions on PV system size. Great. Thanks for that. Looks like everybody was listening. So to start off, I'd like to ask, thinking about how retrofit designers and building owners tend to treat solar PV, what needs to shift for designers and owners to really start to embrace solar PV and take real steps to incorporate it into their retrofit strategies? I think we've got, our folks are muted here. There we go. Ben, do you want to take a first crack at that question?
Yeah, maybe I will take a first crack just because, I would say in all honesty, we typically don't look at solar for a lot of our projects. And just seeing the positive cash flow that can be generated, I think it's a good news story to be included. And I think one of the big takeaways for me was to be able to have that conversation early on with the ownership team and your client to really understand what their objectives are and to better define the financial case that they're working with. We traditionally go right after performance and equipment and solving problems, but we're not great at having upfront conversations around how projects are getting financed, for example, what budgets might look like, what key priorities are. We're getting better at it. We do have those conversations during the energy study phase where we will, we get some owners who think that they're perhaps Warren Buffett. And so they have us use discount rates that are quite aggressive, and we have those conversations, but that's pretty rare. Most people are not thinking that far down the line, even about what metrics make sense to their project or what their goals might be financially. So I think if we can start opening that space at the same time that we're having the conversation around the systems we're proposing and the performance that they're looking for, if we have that early, I think it opens the door to solar, because solar, the conversation around solar is really a story around finance and around cash flows. And that's just not a usual conversation that engineers and designers and architects have. So I think that's maybe part of the missing piece, but yeah, maybe Ken and Ed have something to add to that in terms of what they've seen in trying to get projects off the ground.
Yeah, one of the things that we're finding is that it's important to at least start the conversation, because if you're doing other retrofits, there might be an opportunity to put in some infrastructure like, conduits, raceways, things like that. You mentioned earlier, Ben, looking at reinforcing the roof for an HVAC. That might be situations where then you consider the loading for the solar, or you put in the raceway down to the electrical room, and that gets done. Doesn't mean the solar has to go ahead with that portion of the project, but at least now you're prepared for it whenever it does come. It probably will be something that's just going to happen eventually. The case just keeps getting better and better.
I would maybe add to that. just to say, really, it comes down to education. Most people have a preconceived notion about solar that's not true anymore. Maybe they looked into it 10 or 15, 20 years ago. Modern solar is so much different than it was even 10 years ago. So really, solar can for 95% or higher of buildings can have a major positive impact. So it's really an education game. And I would encourage people to look into solar right from the beginning, because it can influence what you're planning to do as far as retrofits.
Ken, while you're talking, I'm wondering if you can speak a little bit to the benefits of a company integrating roofing with solar specialties.
Do you mean like why we got into it, or?
Yeah, partly, and the interaction between solar and roofing. We know that there can be impacts on warranties, for example.
Absolutely. Well, solar was a natural fit for Penfolds because we're roof specialists. We already have that infrastructure. We're up on roofs. We're waterproofing experts. It's important to choose the right solar installer, and roofing is a big consideration, because typically when you install solar on a roof, it will void your roof warranty. With Penfolds, we wrap your solar warranty and your roof warranty together. And because we're really the only roof and solar company able to do that, that's a major benefit. If anything was to leak in the future, you want to avoid the finger pointing between your solar installer and your roofing contractor.
That's a good, oh, sorry.
Yeah, and then, you know, there's other benefits as well. If you're planning solar, then the type of roof that you choose will have an impact. So we can advise you on better roofs for solar. So for example, we do PVC roofs for flat roofs. They're fully recyclable. No roofing product is that sustainable for a flat roof. But a white PVC roof means that you're going to have less of a heat island effect on your building, which is good. But you're going to get a bit of an albedo effect. The sun will bounce off of that, and your solar is going to produce a little bit more. And, you know, kind of a trend right now in the solar panel manufacturing side of things are bifacial solar panels. So depending on your roof and your situation, typically bifacial are only good for a ground mount system, but they're not that much more expensive, but they produce energy from both sides of the solar panel. So if you have a white, good reflectance on your roof, it's going to really increase your power gain.
That's a good flag. And just, you know, Ed, maybe you can make a comment about how you interact with the roof and roofing contractors to make sure that you can avoid those conflicts.
Yeah, we spend a lot of time not only developing products that, you know, will ensure that the roof's integrity is kept in place, but then the main component of that is training, just getting people trained and making sure that they're doing the installations right, you know. And I think so far everything seems to be going in the right direction. You know, people are taking the care that they need, and you know, that helps in also protecting the industry to make sure the industry goes forward in the right direction.
Right. Ben, I'm curious about when you're looking at the significant building electrification, how are you managing or mitigating demand charge increases within your financial modeling? And there's also the questions around, and maybe Ken can speak to this a little bit better, but does the solar reduce the required electrical service upgrade size that might be imposed because of heat pumps? And was that potential electrical service upgrade included in the costs?
Yeah, I can touch on some of that, and I think Ken will be able to add more detail. Typically, a lot of engineering firms, and ours is no exception, we will typically use a blended rate for electricity. that blends the cost of the demand charge and your usage charge together. But as Ken pointed out in his presentation, it can be important to look at the step 1 versus step 2 increase, as well as the particular demand charge as well. So if you're doing a significant electrification project, that is important to look at. I would say it's not done very well in the industry right now. And it's actually a conversation we've had with BC Hydro to do some education or to provide some tools for owners or for the design community to more easily calculate what a particular customer's increased cost might be based on demand and based on usage. So I think it's not well understood, and we typically use a blended rate for those reasons. Yeah, I'd say it's a challenge in the industry right now.
I would just add to that, and Ed's really an expert on this as well, but for this particular project, they're billed in as a residential rate. So there are no demand charges with residential. When you get into the commercial rates, small general service, medium and large, a big portion of your electric bill will be your demand charge. And that is, you know, if you think of it as a hose, what's your total demand spike over the last 3 years? That dictates the size of the pipe or the hose. The amount flowing through, the water flowing through, are your kilowatt hour charges. So when you go solar, sometimes it can decrease your demand, but not always. So we have to really take a deep dive into your consumption history. And we can now get what's called green button data, or every 5-minute increment from your smart meter, which will help us analyze how it affects your demand or not.
So Betsy, were you more going towards like where you're doing a lot of electrification and the demand increases, you might have to increase the actual physical service size? Is that sort of, and will solar reduce that?
I think that's the direction of the question.
Yeah, so the issue, of course, with solar is we're dependent on when the sun shines, and so electrical code-wise, we can't count on that as a reduction to allow for those other devices to be connected. So we would have to then add storage. So there would have to be a storage device, battery storage typically. And then that actually has been used to decrease the demand coupled with the solar.
Okay, thank you. And while we're on you, I know there was a BCUC decision today, and I just wonder if you could recap a little bit about what that decision was and how that, you know, what that might change for future installations here in BC.
Yeah, so just to give a little background for those who don't know, BCUC was, in charge of reviewing the application from BC Hydro to change the net metering program with some few adjustments. And it really does need some explanation, because what was going on is some people were taking advantage of the program where the program had a payout for excess energy at the end of the year. So if you didn't use up the energy you produced, you received a check from BC Hydro. And you could actually really, really oversize your system and count on that as a revenue check. So what they wanted to do was put into measures to make sure that it is a true net metering program, which means you're netting off your usage. And that went through BCUC. And they came back with some really positive response. One, they're just going to change the rate at which you're paid out the energy. So you're just going to be paid out at market rate, which to me seems fair. So if you want to oversize your system, now you're welcome to, but you'll just be paid out at this market rate instead of what you were paid out before, was 10 cents a kilowatt hour, or just under. The other thing is for the solar people, we had what's called an anniversary date, and they're going to move that to March. And that's the anniversary date is when you use up your energy. So you produce excess energy during the summer, which, as Ken mentioned, that gets put onto your bill as a credit, and then usually you use up that credit during the winter months, and then everything resets on March 1st now, which is really good for most of the solar systems. And then the other one that they applied for was to have some governance and some restrictions, or the ability to assess applications based on the energy consumption matching the potential generation. And the BCUC has told them that they don't want them to put that in place, that having the reduced rate will be fine. So now people don't have to worry about sizing their system, or their PV system, exactly to the energy consumption. So it's a very positive result. So we're quite happy.
That's great. I know the net metering program has been under scrutiny for a while now, so it's good to hear that there's been a bit of resolution there. Quick question about, because there are two more things that I'd like to get in before we close up here. There were some questions about staging the domestic hot water to have it replaced at the end of the boiler life, whether that was considered. Whether some of these, your costing example included the building envelope upgrade costs, whether they were factored in. So I think those two are probably both going to Ben, and I'm going to end, and Ken, you can think about this question. How do you reconcile the embodied carbon? This is mostly for selfish reasons, because our next webinar will be on embodied carbon. Cradle to gate for PV arrays, which I understand can be around 70 grams per equivalent CO2 per kilowatt hour, assuming optimum yield. Of course, this came from audience. They're suggesting that hydropower footprint is communicated to be around 13 grams of equivalent carbon dioxide per kilowatt hour. So Ben, please start with your answers, and Ed and Ken, you have some reprieve to think about yours.
Geez, I thought I was getting the hard one to finish off there, but Ken's got the hot potato. It sounds like a Planet of the Humans reference or something there, but yeah, I'll leave that to Ken. But it's a good question. So on the domestic hot water staging side of things, we do sometimes leave backup natural gas boilers in place, and that's so that we don't oversize the system and make it uneconomical. Ideally, in this scenario, we were hoping to fuel switch the entire domestic hot water load, and that's why we've looked at the system as we have. I would say the most important point to focus on there is the benefit of actually measuring the flow of domestic hot water at the building for real, because as I said earlier, we've done it just based on design calculations. And what we're finding, and there are some papers, not very much available out there on this, but what we've found in our own measurements across several healthcare sites and multi-unit residential buildings is that the sizing is double or more in our calculations as to what we actually find on site. And so you can get away with that when you're doing a boiler. There's no more footprint. The incremental cost difference is minuscule to throw a few more BTUs at it from a boiler perspective. But if you have to double the amount of heat pumps you've got and storage, the space and the cost there are critical. So I think that's the piece to focus on if we can dial that in as an industry. Ventilation, as we said, and as you saw, we've got that issue solved for the most part. We've got great tools and great incentives there. Domestic hot water is the next domino to fall. And I think we really need to look at it from a first principles perspective to get those systems done right. So that's the most critical piece I would say on the domestic side. In terms of the cost of the envelope retrofit, because it's not gone through for any sort of costing yet, any finalized costing or out to tender for contractors, I don't know those numbers. The mechanical costs we have, and that's been budgeted and estimated by ourselves in-house. And we've got a decent record of getting pretty close to the ballpark there. Some of the assumptions, we don't know yet if there's a major electrical service upgrade required or any major structural work. So that would increase the costs that we've seen there. But so we haven't included for those unknowns. I don't anticipate they're required, but that's a potential risk to the cost.
Great, you just inadvertently answered two more audience questions. Thank you. Ed and Ken, who wants to go first?
Maybe I'll take this one, Ed, in the beginning, because I have analyzed this in the past. It does depend on what solar equipment you're using. But the embodied carbon of the manufacturer, transport, shipping to site, all in, you will reach carbon neutrality anywhere between 2 and 2.5 years of the solar producing on your roof. I respectfully disagree with the audience members' numbers that they gave, especially for what the embodied carbon in our electricity is here. But that's really for another webinar. But but it does depend. It does depend on how well they're producing on your roof, and what equipment you're using.
Fair enough. Ed, do you have anything to add?
Yeah, to add to that, I mean, he's right. I don't know where that stat's coming from, but it doesn't seem correct to me. So it might be weighted in one direction. We used to work with Sharp Electronics, and they made solar panels. They still do it. And they actually did that same analysis, and they came up with 1 year of energy offset the energy it took to make the solar module. So.
Okay, good to know. All right, just one last thought. What is one key idea about integrating solar PV that you want designers to remember as they are planning their next retrofit? A nice quick thought.
Maybe I'll start just to keep the order the same because mine will be short. Just start at the beginning. Have the conversation as early as possible because we ordinarily don't. So that's the opportunity to do it.
Thanks, Ed.
Yeah, and whether it's going to end up as a conversation that continues from the beginning to the end, no matter what, plan for it to happen at some point in the life of that building.
And I would say key takeaway is solar is awesome. Start thinking about it and consider it for every single project.
That's great. All right. Well, thank you all. That was really informative. I'm really excited to, to be able to go back through this and digest it all over again. So, and I'm sure that people will be pleased to go through the slides too when we have a chance to share them. So I'll just take this opportunity to remind everybody that this webinar really is a series that's part of a larger project, which we'll be formally launching in the next few weeks, COVID permitting. We are kicking off with an RFP, which is scheduled for release this summer. We will be looking for multidisciplinary teams to design deep retrofit solutions for low-rise residential buildings like the one presented here today in the Lower Mainland or Victoria area. Teams will participate in a 6-month exploration lab where they will develop concept designs with support from climate, energy, and health experts. If you want to learn more or intend to answer the RFP or want others to know how your company can contribute to such a proposal, we'd invite you to log your information at pembina.org/reframed. The types of teams that we're looking for will really draw from multiple fields, including, of course, architects and a variety of engineers, contractors, builders, retrofitters, and to Ed's point, bringing in the installers and fabricators and suppliers earlier on in a project design so that we can really maximize our innovation opportunities here. When you submit your information, it will be published online, really to help other members of industry and to discover the amazing innovations that are out there that they maybe haven't heard about previously. For our projects, we'll be particularly interested in retrofit solutions that integrate technologies such as prefabricated panels. That was the subject of our first webinar, which is published on our website. All of them will be. High efficiency and low carbon mechanical systems, which we explored in our second webinar, roofing solutions that integrate on-site renewable electricity, today's topic. Also want to consider storage or thermal generation, integrating seismic upgrades, climate resilience, which we discussed during our last webinar, and system controls and monitoring. We want to hear your thoughts on what we talked about today and on integrating solar PV into deep retrofits. So please do fill out the survey that will arrive in your inbox when this session ends. We really do hope that you enjoyed the webinar, and we look forward to connecting with you and all of your friends thinking about the importance of embodied carbon in retrofits at our next webinar. Date TBD, we're navigating summer months, of course. But you can sign up for it at pembina.org/Reframed Tech Series, and it'll be hosted by my colleague, Ghazal Ibrahimi. If you have any further questions about Reframed or are interested in learning how your company can get involved, you can visit, again, pembina.org/Reframed to sign up for updates and register your solutions. And with that, I'm going to thank you all for sticking with us, and it's a pleasure to have you speaking to us, Ben, Ed, and Ken, on integrating solar into deep retrofits. Have a great day.
Thanks, Betsy.
Thank you.